assembly in the place. You have it like from the server, then you have if it's bare metal, then you install Kubernetes there, or you take it from the cloud. So you have that Kubernetes layer added on top of it, and then you run the containers where our applications are running. So we have added more and more number of tools. Now more number of tools have increased the attack vector, the surface attack vector for the bad actors to kind of attack it and get onto your systems and create chaos. How it happens. So we discussed the CI/CD phase, and in that entire CI/CD phase, you can see there are a lot of attacks that can happen at each point. From the starting, when you're writing the code, there can be like it's zero trust. So I know every one of you won't be injecting the bad code, but still there are people who inject bad code into the repositories. One of the very famous one is KCD, which I discuss more as well. And also, we have seen in the past, when some of the employees have been leaving, they accidentally or intentionally add a bad code in a particular piece of software so that they can access it, which is bad. This is just at the phase of writing the code. Moving on, the compromised repo. So the repository itself is compromised. You are leaking out secrets. So there have been n number of cases where we have seen that the secrets have been leaked out, whether it's for the cloud providers, AWS credentials, or whatnot. The secrets are being compromised. Build systems. So the build system itself is compromised. For an application, you use some kind of build system. For example, there was an attack in the Circle CI, which is a popular build system, and a lot of secrets were leaked. There was SolarWind attacks where their build system was compromised. So you have all these compromised dependencies. So for each of the applications that you are creating, you have the dependencies for your application. And if the dependency, for example, you are creating software B and you are using A, which is vulnerable, so in turn your B software also becomes vulnerable because it has that particular backdoor where people can enter your particular applications or infra. Artifact tampering, so that is also another way where you create the artifact and you created something but it's shipped to the registry as something else. So some kind of verification needed over there. And then deploying the compromised code. And these are some of the attacks which are very well known in the ecosystem. Now why we are discussing about this is not that I care about security, so yeah, we are discussing about this. It actually matters. So if you see all the reports from the past, and this one is a very new one, Reversing Labs 2024 reports, where they have given a statement that the supply chain security attacks have risen by, for the particular type of squatting and something like that, have increased by 1300%. Now this is a very big number. Very, very big number. And when each of the attack happens, there are $100,000 which are associated to fix or remediate that particular attack. So this is a very interesting report, and you can see the timeline. It's in 2024, so it has the complete timeline of 2023 in each of the months. What all most popular attacks that happen. You can see SolarWinds over there. You can see the Connect over there. So a lot of attacks, well-known attacks, OpenAI breach. So a lot of attacks which are there that you can see. That is why we are talking about supply chain security, and that is why it should matter. Also, if you have seen one of the initial first keynotes, and you have seen how the government is doing all the UPI transactions, and in the whole supply chain of that, if anything is compromised, then it's our data, it's our transactions that are compromised. So it is required at every piece of software supply chain. Some of the very, very popular attacks which actually created a boom. For example, ChatGPT created a boom for OpenAI. These are some of the attacks that created a boom for the world supply chain security. So Urgent 11 was one of the very big, well-known attack with 11 set of vulnerabilities that happened in the real-time operating system. And this, I'm talking about the OS, which is being used in MRI machine, the accredited actors. So you can see if attacker get access to these machines, it actually is life-threatening. So it's not only the data and stuff, it's actually life-threatening in certain cases. And there were 2 billion devices impacted, and still there are a lot of devices which are unpatched. Yes, when there is a vulnerability that comes in, when there is an attack that comes in, it is associated with the CVE. and then there is a patch that comes out with that particular software, but 2 billion devices, it's very difficult to patch overnight. And these are like, MRI machines and stuff where they are doctors, they are not the engineers who are patching those machines. So they are the pilots who are not engineers who are, they just trust the software. So that is what we are talking about today. Log4j, 5 typos in the back was very famous one. Like it looks, that is good, but it's not good. Executives, so this is very interesting one because that's the bad actor injecting, and that's a very organized way of injecting a particular utility that gives you access to SSHD and get compromised your SSHD and get the access. So a developer became a maintainer, is able to push to the code and then is able to inject this kind of vulnerability that gives the backdoor access of SSHD. And it makes it to the official releases and it makes it to the Linux distributions. So that's how much planning people can do. And people do it. I mean, these are the real attacks people do. So it's not that, okay, I'm saying, but who does it? People do it in the open source ecosystem. Let's try to understand the problem with what, some real practical example. So we all eat a lot of junk food, and on every pack there are a lot of details mentioned. There was like particular labels or particular access that person has been doing, right? So there are labels which are there on any of the packed food, like whether it has palm oil, whether it has what sort of ingredients it has, how much sugar content is there. Is it gluten-free or not gluten-free? Because these are important. Suppose a person is allergic and cannot have a gluten food, so they have to look if this particular package is gluten-free or not. So farmers are doing their job in raising the crops, and then it goes into the packaging in the factory, and then it is distributed to the local shops, and then we all go to the shop and buy it. And we do not care about how farmers have produced the crops and stuff like that. But we do have a lot of things in our hands. We can check the expiry date if somebody is selling the expired products. We can check if it's gluten-free or not, so that we know it's not good for our health. We can see from which manufacturing facility it is coming. So all these are in our dates. And then there are organizations, government organizations, FCCI, and they keep a check on the crops quality, and they keep less check, but these days they are doing more and more, which is good. Factories are practicing healthy practices or not, and local shops are distributing it in a well-structured manner. There are no rats and stuff like that, and then we eat it. So now this supply chain looks good. How about our software supply chain? What is missing over there? This entire thing of, from where it came, who's the author, how can we verify, are there any regulations, are there any best practices for our software? Because it's very same. We are consuming a software and we don't know from where it came from is a big miss. For example, you build a particular package. Now this is the artifact point. You build the package and you are receiving it. Now I ship something that you order from Amazon and you get it tampered. Like, you won't accept that, right? You want everything to be perfectly sealed. If the seal is broken, you won't accept that particular package. We have to do that same for the software ecosystem as well, where we have to build tamper-proof build. Whatever we are shipping is whatever is going to the artifact registry, and people are consuming it. How we are consuming in the software ecosystem, how developers are developing in the modern ecosystem is writing Docker files, and we are just using from whatever image that is. We don't care, developers don't care, because they don't care about security, but we prove that they should care about security. So, Ubuntu latest has a lot of vulnerabilities. Anything latest which is not version trained, and even if it's version trained, then how a developer would check and why they should care. You are running endless things that you need in your application, making it fully bloated application, and then creating a mess on the security teams. So security teams are stretched because in your organization there are multiple teams. In multiple teams, everyone has their own way of writing Docker files, has their own set of repositories that they want to choose from. Some is using apps, some is using YAML, so they want to choose from their own set of repositories. Now what happens when the security team does the audits? They are like pulling off their hairs, like what is this I have to go through? Because everyone is using different artifact repository, everybody, there is no single registry which we audit and they can use the packages from that particular registry, and they are not careful about using the versions. So this is the need for having a private kind of registry where basically the registry is pretty important, and I'll come back to the registry phase. So this is similar to you found a pen drive on the road and you said, okay, this might have a multi-million-dollar secret documents, and just plug it onto the system and the system goes boom. So we are doing exactly the same with the npm install and the Docker pull. I don't know what all things I have used for for my Docker build environments, what all images I have used, from which developer they are coming from, I had no clue. So we are just seeing, okay, this serves the purpose, just do the Docker pull and do it. It might have anything which is vulnerable and get access to the system's password, and then everything is compromised. And these attacks happen. And this will be dependency hell, because we are so much dependent on a lot of dependent software and we are not worried about what is happening. So now that we have discussed the problems, let's try to understand from the same farmer's analogy how we can add the same metadata that we get from the product that we read and we buy from the supermarket, and it has all the information. Now the same thing we can do in the software ecosystem is using SBOMs. So since all these attacks that I just explained, you know, the PyPy, typo spotting, urgent 11, around that time frame, especially post 2019, this became very huge because of the number of attacks that have increased rapidly with the rapid attack surface. Now, SBOM is the same labeling and structuring and giving you all the data about dependencies, libraries, licenses used, who created what for your particular piece of software. And why this became more important is because of the legal rules that US and EU governments have raised. So, White House issued an order M2130 that you have to provide SBOM for the software that you're using. EU has even brought a very strict order that those SBOMs should be of high quality. So there are SBOMs in place, so we are growing in the technology. I mean, there have been foundations and stuff that I'll be talking about, have been growing. So SBOM benefits, it gives you all this information that you can read in the tree, how name, supplier name, component, hash, version string identifier, great detail, easy to compliance, audit, very good for the security teams, and you can easily build them as well and ship it, attach it to your artifact, then security teams can verify all the stuff. Also, the one that you see on the right is SBOM scoring. So this is pretty interesting to get a score which happens to the quality of the SBOM. There are two types of formats, EX, SPDX, and you have the, and they're not that important, they are just the different format of the images, like you have SCG, PNG, but you don't care about that, it's just visible. So these formats are there, but there are tools like Protomon that just read it. Another thing that happened in the tools evolution is ChainGuard coming into the picture, and they giving us a lot of good zero CVE or minimal CVE based images. A very good example of hosted registry, which is patched properly for the CVEs. Although they use very different build tooling, Apco and Melange, and they have their own OS-based OS which is bulky, and they give you these set of images. So if you use any of these images which are there, and they have around 3,000 such packages which are already available. These are CVE free. Now, as a developer, at least what we can do is shift in the security left. We can start using these packages, and you know we have started from zero CVE, and now we will be carefully adding the stuff that we want for the application that we need to build. So build and verification system is pretty important. This was one build attacks remediation. So on any of the build systems that you build, it should be giving the same artifact, like it should be verifiable that the artifact is being created. Again, the next part, after you have attached the SBOM, everything is done. So the next part is very finally signing your code. So you sign your code. You can sign your code. So there's a whole community of tools which is stored. So you sign your code, you verify the signatures, you monitor the activity. How you do that? So there's a developer that can use the OIDC Google authentication and use a simple signing service to sign a particular artifact that you are writing, the code that you are creating, and then it goes to the transparency logs, which is record, and then verify the signature from the logs. Behind the scenes, these are the tools. So signing, Felicio is similar to what LetSencrypt is to issuing you certificate for HTTPS. It does it for those signing certificate authority, and record is the one for the log service. SNSA is the organization. So now you are doing all these things, you can reach different levels within the SNSA ecosystem and get yourself the SNSA levels on the big side of things. So that you can show to the government organizations or to anybody that you are SNSA level 1, level 2, level 3 with the security practices that you are following. This is a scenario, CLI tool for generating SBOM. You can use it. You can use store tooling for signing the artifacts, transparency logs, and then you can use Drive for vulnerability scanning. What should be your strategy? So ending this with you have a single package manager, think beyond the current build system. So we will talk about next. High quality response, automated patching, zero trust, also shifting security to left using some of the tools for chain guard images and GridSafe. GridSafe is something I and my friends recently launched, which is open source. It uses Next. So basically you can actually create the plan is to create a repository, private hosted registry where you will be having the packages, Next packages that people can download easily. So there is no such tool like Defender-Bot right now for the OS packaging, OS patching or OS dependencies in a declarative way. So GridSafe provides you to do it in a declarative way. So you can see bsf.scl file, the development packages which are required for your application, and you just do GridSafe init, GridSafe build, and GridSafe deploy to deploy the application, and you can also create OCI artifacts. So just leaving you with the final thoughts. I think Indian governments also need to raise more regulations. There has to come more regulations from the Indian ecosystem. OpenSSF, which is the Open Secure Security Foundation, which is very important. You should have a look at that in the projects that it hosts. Trustee by StackLock, build safe, chain guard images, and those are some of the things that you should be. Okay, so what we discussed today is the need for what supply chain security is from the CI/CD ecosystem, where we are with the commerce analogy that we have everything for the food we eat, but not for the software we have. How we can do it is using the SBOM, creating that, signing and verifying the code that we have, and then using the right set of images which are CVE free. So everything coming to the left, so people can easily search using GridSafe also. You can easily search for a package, see which dependencies have what vulnerability CVE. If there are zero CVE, you just use that easily. So this is something that you can do. Yeah, that's it. I hope you got a gist of supply chain security and what it means and some of the tools that you can use and start implementing in your organization. If you want to talk about ChainGuard, GridSafe, any of the supply chain security stuff, do contact me, Rishit, Harsh, we all are here, who are the contributors for GridSafe. Thank you so much. That's my